everybody. So we are going to talk about double replacement reactions, and you are going to be doing a lab, and that lab is about precipitation reactions and double replacement reactions. Now, double replacements are ones that we haven't talked about yet, but that's what this video is to help us out for, to try to explain what you're going to do in your lab as well. Now, a double replacement reaction is where you have two reactants that are compounds, and then when they react, they're actually going to break bonds with what they're bonded to, and they're going to swap partners. So let's just say that we have like two couples, and like one boyfriend-girlfriend, another boyfriend-girlfriend, and they decide to flip-flop the girlfriends decide to flip-flop their boyfriends. That would be like a double replacement reaction. Now, in your lab, you're going to see that you have a data table that's set up like this. So here's your data table. I want to look at doing a few reactions or a few examples for double replacement reactions. So specifically, I want to look at a reaction between silver nitrate, and then I have Ki here, which would be potassium iodide. So let's just do some examples so you know what these reactions would look like. So we have AgNO3, and we're going to react that with potassium iodide, and that's Ki. Okay, so in a double replacement reaction, what will happen is that the cations are going to flip-flop their partners. So I'm going to figure out, in these two compounds, which ones are my cations. Well, you know that the cations have the positive charge, and we always have to write those cations first in a compound. So silver has a +1 charge always, so that's my cation there. And potassium has a +1 charge, so that's my cation in potassium iodide. Now, silver right now is bonded with nitrate. But whenever I react these two, it's going to switch its partner. So I'm going to get silver wanting to bond with iodine. So now I'm going to produce silver iodide. So when I write this, I have silver and I have iodine, but remember I can't just write AgI. I'm going to have to use those charges because this is an ionic compound. It's between a metal and a nonmetal. So silver, we know, has a +1 charge. Iodine has a -1 charge. So in this case, it is just as simple as writing AgI, okay? Now, I can't leave the other two players in my reaction. So I make silver iodide, but in my product, I'm also going to make something else between potassium and nitrate. Now remember, in our compounds, we always write the cations first. So my cation here that's not accounted for is potassium, and that means it's going to bond with nitrate. So potassium has to go first because it's the metal and it's the cation, so it has to always, the cation always goes first. And then NO3, you know, is nitrate, so that's my anion, and it's going to go next. Okay, well now I have to balance with charges. So potassium has a +1 charge, nitrate has a -1 charge, so that looks good the way that it is. So my formula, or my chemical equation, would be AgNO3, so I have silver nitrate, reacts with potassium iodide to produce or to yield silver iodide and potassium nitrate. So in this case, all they did was flip-flop their partners. Silver used to be attached to nitrate, but now it's attached to iodine. Potassium used to be attached to iodine, but now it's attached to nitrate. So all they're doing is flip-flopping those partners. Now, since this is our chemical reaction, of course, we're going to have to make sure that it's a balanced chemical reaction and that this can happen. So I see I have one silver, one nitrate, one potassium, one iodine, one iodine. So we're good and balanced. So this is a pretty easy one. But I want to do another example where we're probably going to have to use some coefficients here, okay? So let's actually just go to potassium iodide and let's do lead 2 nitrate. Okay, we're going to try this one. So we are going to react potassium iodide with lead 2 nitrate. Okay, so big question first. How do I know that in this compound lead has a +2 charge? How do I know that it's not +4? I would look at the charge of nitrate, and I know that the charge of nitrate is what? It is -1. So since nitrate has a -1 charge, and I have 2 of them, gives an overall -2 charge. And I know that I only have 1 lead, so that means that the charge of lead must be a +2. Okay, so in this case, I want to make my products. This is what I'm given as my reactants, and now I need to predict what my products are going to be. So, like in a double replacement reaction, I know that the cations are going to crisscross partners. So I have to determine which one are my cations here. Remember, those are the ones that are first. They have the positive charge. So potassium is my cation, and I can see that you cannot see that yellow. I am sorry. Okay, potassium is my cation on this compound, and lead is my cation on the second compound. So now I need to just crisscross their partners and then balance those compounds with charges. So in this case, potassium was with iodine, but on the product side, potassium is actually going to swap partners, and it's going to pair up with nitrate. So I'm going to get potassium, nitrate. And then I'm going to balance with those charges because I'm not done. I can't just write the symbols. I also have to balance with charges. So potassium has a +1 charge, nitrate has a -1 charge. So in this case, it's just going to be KNO3. But then I have to react the other two. So lead is going to react with iodine. Remember, it's going to swap partners in that case. So then I'm going to have lead and iodine bonded together, but what's my charge of lead? It was a +2. So if lead has a +2 charge and iodine has a -1 charge, how would I write that formula? Remember, we have to crisscross them. So it should be PbI2. Okay, so let's write out our entire reaction, and then let's also balance using coefficients. So we have potassium iodide reacts with lead 2 nitrate to produce potassium nitrate and lead 2 iodide. Okay, the only thing now that I have to do is add coefficients in front because I know this is not balanced. I have 2 nitrate ions on this side, but I only have 1 on this side. And I have 1 iodine on this side, but I have 2 on my reactant side. So, if I have 2 nitrates over here, let's write a 2 in front of here. That gives me 2 nitrates here, 2 nitrates here. Well, now I have 2 potassiums, but I only have 1 on this side, so let's add a 2 here. Now I have 2 potassiums, 2 iodines. I have 2 iodines over here. I still have 1 lead. I have 1 lead over here. Okay, let's do one more just to make sure that you're good on writing these double replacement reactions, okay? So let's do the one just underneath. We'll just finish that column. So we have potassium iodide reacting with calcium chloride. Okay, so potassium iodide is going to react with calcium chloride. So in this case, again, double replacement reaction because I have 2 compounds here. So what's going to happen? They're going to swap partners. And specifically in this case, I look for my cations. That's potassium and calcium. And then they're just going to crisscross who they're bonded with. So potassium's now going to be bonded with chlorine. Calcium's now going to be bonded with iodine. So if you had to write the products out for this, I actually want you to try to do that on your own right now. See if you can get this. So potassium is going to go with chlorine and calcium is going to go with iodine. I want you to try to write those two compounds, those two products by yourself. Okay, let's see if you got this right. So potassium, again, goes with chlorine. So I should get KCl. And why should I get KCl? Because K has a +1 charge, Cl has a -1 charge. So it's going to be KCl. I'm also going to produce calcium iodide. And for calcium iodide, you should get CaI2. And that's because calcium has a +2 charge. Iodine has a -1 charge. When you crisscross those charges, you get CaI2. So let's write out our entire reaction. We have potassium iodide reacts with calcium chloride to yield potassium chloride plus calcium iodide. Okay, well now I have to balance because it's not balanced the way that it is right now. I have 2 iodines on this side, so I only have 1 on this side. Let's add a 2 out in front. So now I have 2 iodines, 2 potassiums, but I only have 1 over here. Let's add a 2 here. And my potassiums are balanced, iodines are balanced, chlorines are balanced, and I have 1 calcium on each side, so we're good. So we get 2, 1, 2, 1, okay? Now, what I would like you to do for your homework is I would like you to complete 12 more double replacement reactions based on this worksheet here. So you can just pick whichever 12 that you want to do. We did 3, so you have 21 options left to you, but I would like you to have 12 double replacement reactions that you have written that's from your lab, okay? The 3 that we did together do not count, so you have to do 12 different ones. And that's going to be due whenever you get into class at the beginning of class on Monday, okay? And if you have any questions, remember just post on the blog and I will answer them as quickly as I can. I hope you guys have a really great weekend and I will see you on Monday. Bye!